In my hand, there's just a simple magnet, something almost everyone has seen before. But here's the interesting part. If you pair it with a double hook spring, you can actually turn it into a fully functional and surprisingly efficient antenna, capable of picking up signals you wouldn't expect. Sounds surprising, I know, but that's often how science takes the simplest things and turns them into something useful. I prepared a small piece of wood, 17 centimeters long and 8 centimeters wide, and you can easily verify that yourself. The magnet I'm using has a diameter of 6.5 centimeters, and the double hook extension spring I'm using measures 10.5 centimeters in length. I'm going to lay the magnet down and secure it near the end of the wooden board on the horizontal surface, just making sure it won't slide out during the process. After applying hot glue to the spot where the magnet needs to be secured, I'll press and hold it for a moment so it sticks firmly, making sure the magnet doesn't move during use. At this step, I'll be using the 2 hook-end springs and finding the most suitable spots to secure them onto the magnet. Do you think I placed it nicely? Drop a comment below if you can spot an even better position. In my hands, I have 2 short pieces of wire I prepared earlier. I'm going to connect either end of each wire directly to the shorter ends of the 2 extension springs. Once the wires are connected, the next step is to secure the extension springs onto the magnet. I'll apply hot glue to the spots where the extension springs need to be secured, pressing and holding them for a moment so they stick firmly to the magnet, ensuring they won't move during use. And now, the connection between the 3 components, the magnet, the wires, and the extension springs, is firmly secured, ensuring a stable and effective signal reception. I'm going to apply glue to the joints between the components to prevent any exposed wires. If you made it this far and find this topic interesting, go ahead and hit like and subscribe. For the remaining ends of the 2 wires, I'll connect them to the female plug, completing the circuit so the antenna can function properly. And all you need to do is remove the casing of the plug, then connect the remaining ends of the 2 wires to the internal terminals of the female plug. Let me tell you a fascinating story about a hook-end spring, a seemingly ordinary object that once helped change machine design. In the 1950s, American engineer Robert L. Thompson worked at a small mechanical factory in Ohio. He faced a problem that seemed simple but was tricky: how to make small parts move smoothly and return to their original positions without complex components. Robert tried many solutions: gears, rods, traditional springs, but all were bulky or prone to failure. One day, while dismantling an old extension spring, he had an idea: use a hook-end spring, combining the hooks to both connect parts and provide pulling force. He tested it and was surprised. The mechanism worked flawlessly, saved space, and reduced complexity. This invention not only made machines operate more reliably, but also became the foundation for many modern designs: car seat springs, mechanical keyboards, and small robot suspension systems. Robert's story shows that ordinary objects can lead to breakthrough solutions if approached with creativity. Innovation isn't always about grand ideas. Sometimes it lies in the small details we often overlook. Once the connections are done, I'll secure the female plug onto the wooden board with hot glue, positioning it near the edge for easier access when plugging in. So far, we've completed roughly 70% of the setup. Now, the only step left is to add the intermediary conductor from the antenna to the TV. To carry out this step, the TV antenna cable is essential, as it serves to transmit the signal from the antenna to the TV. After removing the casing of the male plug, I'll connect one end of the cable to it, allowing the homemade antenna to link up with the female plug. I'll get straight to it about how a TV antenna cable is built. For those who haven't seen it before, basically it consists of 5 interconnected parts. First is the central conductor, usually copper or aluminum, which carries the signal from the antenna to the TV. Surrounding it is the inner insulating layer, preventing the signal from leaking out. Outside this is a shielding braid, typically a copper or aluminum mesh, which blocks interference from other devices. Next comes the outer insulating layer, protecting both the shielding and the central conductor. Finally, the outer jacket, usually made of flexible plastic, resists wear and environmental factors, keeping the entire structure stable and secure. So, one end of the cable is complete, and the other end is connected directly to 2 types of F connectors, a straight connector and a 90-degree connector, providing flexibility when linking to the TV or other devices. So now, the antenna assembly is complete. All components, from the magnet extension springs, wires, to the cable and connectors, are firmly in place, ready for testing and use. With over 30 years of experience repairing and installing electrical devices, I can confidently say that this homemade antenna functions perfectly fine. While it may appear not very sensitive at first glance, the way I combine a magnet, extension springs, wires, and connectors creates a stable signal path, ensuring that the signal from the antenna reaches a TV without significant loss, even under challenging conditions. The reason it isn't as sensitive as commercial antennas is simple. Industrial products are made with optimized materials and techniques, often including internal signal amplifiers, better shielding, and specialized wave separation designs. In contrast, our DIY antenna uses simple materials and a homemade design, so its ability to catch weak signals, especially from distant transmitters or through obstructions, is lower. Nevertheless, under normal home conditions, this antenna is perfectly capable of receiving basic channels. From my long experience, I know that a continuous signal path and solid connections matter more than unnecessary complex components. Using hot glue to secure the magnet, springs, and wires not only makes the device durable, but also reduces the risk of loose connections or broken circuits, which are the main reasons DIY antennas fail. I also ensure that the F connectors were installed correctly and the cable is well protected, minimizing interference. For anyone who loves DIY projects and wants to try, this is proof that with patience, attention to detail, and basic electrical knowledge, you can build a working device even if it isn't as high-end as commercial products. And if you find this topic interesting, don't forget to hit like and subscribe to follow more tutorials I share from my years of practical experience. I promise there are plenty of small tips and tricks to help you build effective DIY devices. Finally, remember that every experiment is a learning opportunity. Every connection, every secure component, and every signal check is valuable experience. The device may not be perfect, but it works, and you built it with your own hands. That is the real value. So if you found this video useful, subscribe, and share to explore more exciting electronics creations together, which will surely impress you.